Hello everyone. So this is about the decentralized property registration and management platform. In here, uh, the project name will be Metaspark, and so the description about what we are basically trying to do is we are going to develop a system that will eliminate most of the frauds that we come across the current property registration mechanism. In addition, we will be developing an entire platform that will help to manage these transactions and also help to reduce the overhead with some other related activities such as like calculating the tax and getting the evaluated land price, property price, and also the court judgment predictions. So so when we consider about the property registration, so here there can be so many issues because validating and verifying the transactions is completely it's like it's not done according to a proper standard, because we will always be rely on the handwritten signature. And also the transaction, for example, if a land was transferred through a deed, so the entire registration process may take some time. It will take more than a day, it will take around 1 month at least. So within this period, user can actually the seller can trade his land for another person as well. But there are certain rules and regulations that you can impose in order to avoid this, but most of the time, yeah, this is possible. And also, all these even though all this information is public, accessing them is very difficult. We will have to, so in Sri Lanka we call them as pattiru. So it's very difficult, it's a heavy process. People have to visit and get these forms filled, and we tried it during the research, and it was very difficult. Also, the evidence, the approvals, the processing of the transaction, it's not transparent, because we don't know where our deed is with and how it is being processed, and everything is documented. There are some applications that were developed to help this, but they were not they are not live at the moment. So yeah. And also, one of the other main reason that one of the other sector that we are looking into is the judgments, especially with the court judgments related to land disputes. So here, most of these land disputes are very similar. So when we've contacted few lawyers during this research, and we got to know that based on his experience, for example, if a 10-year 20-year lawyer uh, based on them, so they said they said all the cases are very similar. But the problem is that if each and every single issue, it drags up to so many years, even though both are similar, and the judgment is almost same for every uh, case. Even at the time they study and even when they practice, it would be the same result, but still it takes so many years to come up with the result, to resolve the problem. So we can actually solve this, we can actually predict the result. uh, but if not very complex situations, some likely cases, so we can predict what would be the outcome. So this is one more objective. So these are our main objectives. So as a team, we try our best to uh, improve all the standards, all the quality of this application by the technology side. So this is our high level architecture of the application. The proof builders, so this is we are using a decentralized public blockchain. So blockchain is nothing new, but in Sri Lanka there are very less applications. I think there are no much of applications that are using public blockchains. So public blockchain is a concept that it will be very transparent, and by the way, we have to secure some of the confidential data, sensitive data. So that also we have a mechanism. And also we will the best part of this application when compared to the whole world is that this application, the users will be interacting. So the users means the general public, the stakeholders, everyone will be interacting with the chain. So whereas most of the other products were only the administrators will be interacting with the product. They will they will it's like a data entering application. That's what I see. But here it is a entire project, it's an entire application. So this is a very good idea. And Yeah, so we have several mechanisms on securing our process during this. And we are predicting the land value, and we use this public blockchain to manage all the information, and we have a chain of identifications as well, and also the code predicts. Yeah, so the research problem, um, and the research gap. So I hope now there's a very good understanding on what the project is, and it's very clear that what's our research gap and what we are going to do. So some of the existing systems, so there are so many systems built, not so many, but there are few systems built. Um from them, some of these applications doesn't actually are live at the moment, but from the live applications, I think they have around 2 or 3 features from our application. So we have a huge set of features. And so as you can see, most of these are no at the moment. And yeah, so the methodology, so we have a target, we have a plan how we are going to build this application. And yeah, so this will be our heart of the application, so the blockchain architecture, so how we are going to manage. So one main thing when we are selecting a blockchain is that, especially a public blockchain, is that we have to be very firm with the transaction fee. So we have to have a very good understanding how the transaction fee varies. So in a future, if we select, for example, if we select an Ethereum based chain, it's very expensive. But at this beginning, it might be very cheap, so we might have moved to that. So I have when I was doing going through this research, I figured out that there are some applications which were built on the Bitcoin blockchain as well. So now we can understand how to do transactions through Bitcoin, because it would be very expensive. um, so at the time it came into existence, it would be very cheap. So we have to build this system in a way that we can actually switch into another blockchain very easily. So yeah, there are several contract migrations and different kinds of technological stuff. But however, the basic implementation, the basic features of our application should not be changed, should not be disturbed by the blockchain. So it should be very independent. All these entities, all these components should be very independent. So that's something we are going to achieve through this um application. So we have already started implementing this project, and we have come to a very good state. So these are the kind of proofs. So I'll explain what are the proofs. So we have around few proofs here. So you can see we have 7 proofs. And so one of the important proof is that the proof of chain of custody. So here you can see that this is the genesis transaction. So this is the origin of the transaction, this is the origin of the land block. So maybe at a point we will not be able to find this part, because we don't know how this land came. So we can consider this as a genesis, and then move on. So somebody purchased the land and it will be recorded, and somebody have it, somebody transfer it, it's recorded. And this is actually a split. So this land is split into few other parts. So this doesn't matter whether it's a land or it's a property or whatever. So it doesn't matter, it's actually transaction splitting. Okay, so and then it is again transferred, this split. Okay, so this initial land might be, we can expect it's a 60 perch land, and then we broke it into 20 and the 20 perch land is going there, and here there's another land that is coming, and then we are merging these lands. So when it comes to chain of custody, the splits and merge is a bit complicated, because we have to maintain the proof of history and the state. Because for example, now if land E is connected to land B, we can expect that land from land B, the north is land E and the south is land D, uh, and land C is to the land A, and land C west and east and everything. But the problem is, now if land A splits into 2 parts, so it can be either land F and G or it can be to the land, more towards the land B or the land over here. So at this state we have to maintain the transactions in order to map these future needs. So for example, a land cannot be added in between these things. In between these four lands, a land cannot be added unless one of these land break. So break means it's gonna split, right? So if this land E splits, then yeah, of course you can have a land here, but again it's connected to all. So that's what's the proof of history and state is. So the land prediction system. So land prediction system, there are several land valuationing patterns and some other technologies associated with land prediction. But there are some unique features on this land prediction and the tax calculation, the features that we consider especially for the country. So we got all this information by contacting. We went physically on these premises and we got information from them on how they currently do the land evaluation. So this is actually a estimate. It's an assumption. It is not a perfectly um, it's not actually the perfect value. So they try to have it to the minimum stage. That's the main expectation of them. So yeah. So but there are some cases that we need to manually go, because for example, if the land is not even, if the land has some other faults, if the land has a stone underneath, so these are some common issues. So in that case the prediction price goes wrong. But through through visualizing, what we can see is the flat land, right? So yeah, so there are some exception edge cases as well. So that's why there are some other features that we will look into. And the land dispute prediction system. So the land prediction dispute prediction is a very important feature for this application. So there needs to be a very perfect data set in order to this for. So right now in Sri Lanka, most of these information is handwritten. Most of these information are stored in documents as papers. So in that case it's very difficult to gather information, because it would take too much of effort for that. But what we can do is there are actually mechanisms of getting data. But the best thing is we can use the new data, new on-chain data, or the new cloud data, and we can map this, and we can predict the land disputes. So yeah. And then we have the deed generating system. And yeah. So these are the technologies that we are going to deal with. We are going to go with most of the latest and the fastest technologies. And these are the other technologies also. So some of the technologies that we are going to use with, and the functional requirements. So yeah, so I'll get into the functional requirements during the demonstration, and the non-functional requirements. So from the non-functional requirements, I would think when we because we are using a public blockchain, so availability and the performance should be like the key factors, because uh, transactions in blockchains fail most of the time. And we are selecting the Stellar blockchain because it is very cheap. It's having a very cheap gas cost. But again, the transaction signing and everything, it requires a lot of work in it, because it doesn't have smart contracts. So uh, we will be developing some libraries that will extend the capabilities of this public blockchain. So there are no any open source developments done so far to support transaction signing and all. So we will be developing this as well. So the commercialization. So commercialization. I hope if you followed me through this up to now, this project is uh, very valuable. And for our country, this would be a very good turning point, because we are going to use the modern technology. We are going to work with one of the latest technologies. So I know it is very difficult for gather all the users for the system, but we can gather most of the users. And the digital tokens. So digital tokens are cryptocurrencies. So these cryptocurrencies, we will not stick into the native currencies. We can issue our local currency, and users can keep it. So it will be a virtual bank. And each of these land plots, so if you consider here, each of these land plots will be a NFT. So users can purchase these NFTs and they can develop applications over this. So that's some of the uh, important um, yeah, important mechanisms. And we have the subscription plan for digital tokens and proof verification. Yeah. So availability, um, yeah, we expect the support of the government for this, because this is it's a free application uh, for all the users, and it's having a great objective. Yeah. So this will be actually the first public blockchain based land property tracing system in Sri Lanka. And the next we have a budget. So this budget is like for around so we this is actually calculated in USD because we are dealing with cryptocurrency. So you can see it's around 155,000 at the time. So this calculation was done when the USD price was 209. So now it would be much higher, but the thing is, it is not for one property. So for one property it would cost around 50 rupees, so it's less than the stamp cost as well. Yeah. So let's move into the demonstration. So this is the demonstration. So initially this account needs to be created by the government. So with the current so we heard about that there is a digital identity card going to be uh, issued to the public, so we can use that here. But for now, this logging, uh, the user creation should be done by the government. So yeah. um, so first, user identification number is required, and then the password. So these both has to be given to the user by the government. So this can be on premise, and then later on user can continue with the process. So user needs to enter a mobile number. So let me enter mine. So here the request is not actually going because we are still testing the application. So we don't need to spend unnecessary amount spendings on verification codes, but we have tested the feature. So we get the 6-digit verification code. So now we have enabled mobile authentication. So now user account is established. But you can see none of the details cannot be edited. These are permanent, and then you can see here the account is not approved. So once the mobile number and the passwords everything are done and updated, so then user can actually request account approval. So we will be manually going through each of the accounts, and then we will approve it. So from the database I will do the approval right now. So still the administration dashboard is not developed. So I'm the only person who's developing this application, this entire component. So yeah. So okay. So now we have I think now we should be able to use the application. So first let's enable two-factor authentication. So two-factor authentication is I hope everyone knows about two-factor authentication. So we can actually secure more. It helps us to secure our account. We need to have the application with us. So this is an application-based two-factor authentication. Mm, okay. Okay, so the two-factor authentication has been enabled for this account. So let's update the um, let's add an email as well. So actually these email should be updated before account approval actually. So let's send this verification mail, verification code. Okay, so it's sent. Let's wait for it. Okay, so we have it, and let's verify the email. So yeah, email was verified successfully. So let's see whether we have it. Let's refresh it. Yeah, so we have it as verified. Okay, so let's re-log in back. Let's see how is the user interface after we log in. So we can see first it will validate the SMS authentication. So the code is 550586, right? 586. So verify and enable. Okay, so next when we so here we need the two-factor authentication code because we have enabled it. We cannot access any service without it. So let's say verify code and verified. Okay, so now we have it. So let's move into the important let's move into the primary account verification. So we have to confirm password as well sometimes. So this is again, this is actually valid for 2 hours, um, and then you have to again validate it, um, but only if the device changed. So if you open inspect elements, then you will have to validate it again, because the device is changing. So the next step is so update an SMS, and yeah, these are the primary security measures and the two-factor authentications. Let me disable it for now. And then we have the blockchain identification. So the transaction security, this is one of the important part of it, of the application, because now a transaction signature. So we all know you have used MetaMask and different kind of applications, but in Stellar we use a transaction. So in every blockchain, what we have is we have a public key and a secret key, but the secret key is very large. We cannot actually remember it, so it's impossible to remember. We save it somewhere, but when we are using a system like this, because we will have so many accounts, so how can we remember all this? That's not going to be possible, but we can remember one transaction password, right? And to make it more simple, we have a transaction signature on top of it as well. So this kind of a mechanism, I have not seen at any workplaces I have been so far. So what we are going to do is we will be having a transaction password, which is a very simple transaction password, and then we will be having a transaction signature, which is very which we can save it. But by the way, you can update the transaction signature if you know the transaction password, and thereby every account that you are going to create here, you will be using the transaction ID that you just created, transaction signature ID. So let's see what it is actually. So let me create a simple password, 1234567 So just created the simple transaction password, and so I'm going to generate a RSA public key and a secret key pair. So you can actually save this. You can copy this to clipboard, so you can save it, and also it's better to have a download button as a text, so you can have a download button as well. Yeah, so now what you have to do is you have to enter your current transaction password, and you have to save the secret key. So make sure you remember the transaction key. I mean, you save it somewhere, okay? But that's not important if you can remember the transaction password that you gave. Okay, because whenever you update the transaction password, this transaction signatures key will be updated, and every account that you're going to import to your system is based on the transaction signature. So thereby it's very unlikely that so that you don't need to remember, actually the system does it for you. So let's import a blockchain account. So let me say this as a test account. So we have wallets as well. So let me select this as a wallet account. So wallet accounts, let me generate a key pair. So these are actually blockchain account key pairs. You can copy and save it, but you don't need to actually, because you will be having around thousands of accounts with this system. Okay, so you have created a blockchain account successfully, and you can list them actually here. So you can see you have it. So balance is still processing, so fail, no account, so you don't have a balance actually. Okay, let me create another account, test2, but this is going to be uh, a channel account. So channel account means that you don't need any single rupee for this, sorry, single penny for this account. So you need to select a sponsoring account, but you can see this sponsoring account doesn't have lumens to sponsor this the new account we are going to create. So we have to fund the selected sponsoring account. So this funding this will so this is actually a testnet funded, so you will be funded with 10,000 cryptocurrencies, but this is a testnet. Okay. In real case you will have to buy them, you will have to buy the cryptocurrencies required. And then you can see now you have 10,000 lumens, and you're going to create payment channel. Okay. And in this process you will see the sign in transaction pop up. So this is something completely new. So the Stellar, there is no any transaction signing like this in Stellar, where you can see each and every information related to the signature. And also you can I'll brief on this transaction later, but here you can see you have all the important operations that you can see here. And also you can group them by the user, because you will be multi-signing these kinds of applications, right? So you in this case you will need the signature of uh, the new account and the sponsoring account. So maybe the sponsoring person is the lawyer, is the head of is your lawyer, maybe the counselor, and you are a junior. So you need your accounts being sponsored. So if the system is used by lawyers, so that then that case you are sponsor, the lawyer should actually sign it. What you can do is you can you can generate this signature. You can get this transaction online and send it to the user, and then he can sign on it and submit it. So let's you can also pre-authorize the transaction. So I'll get back to this in a while. So for now I'm going to sign transaction envelope using Metasploit. So you can actually use any of these mechanisms. So Albedo is the open source transaction signing for uh, Stellar Foundation, Stellar blockchains. But we have more features than that. So I think you can see the risk. So the highest risk is for him, for this user, which is HBX. So let's go with HBX and confirm. Okay. Okay. So sponsoring failed. Okay. Okay. Let's sorry, so earlier I didn't actually sign the transaction, I just confirmed it. So you need to first sign the transaction, and then you need to confirm, because once you sign, the transaction will be signed, then only you can actually submit the transaction. So here the transaction will take some time to be submitted. So once confirmed, yeah, transaction channel was created successfully. So this is a channel account, so you can listed payment channels through this. So you can see here you have 0 lumens and the account is available. You can actually explore this account, and yeah, you can actually merge the account. So merging requires a destination account. So these are a bit complex activities. I don't think you will need this, but it's better to have it. Okay. And then the identification. So identification is that user will be identified within the system through a public key and a private key. So we have just one wallet account. So let me in order to avoid confusions, let me create another wallet account saying identity one. So identity one is a wallet account. So okay, I'm gonna generate the key. Also you can import existing keys if you have one. So if you don't have, you can create it. Okay. And okay, so it's created. So you have wallet accounts, you have two wallet accounts, but one is failed, there's no account because you don't have money in it. So the account is not activated. Okay. So let me go for the blockchain identification. So here you can select the second one. and set as identification is not existing or invalid. As I said, it is not existing because you have not funded the account. So let me fund the account first. um, Fund the account. Okay, so the account is now funded and it is available. Okay, so this is QV. Okay, so let's go to the identification and let's okay, and let's okay, so now you can see you can sign the transaction. Okay, so now this is a multi-signature transaction. So here the second signature, the second signature, you can see this is a multi-signature transaction and this is from our side. So we will have to pay 400 troops for this transaction. So 400 troops is very less, very less. 10,000 troops is going to be one lumen. So one lumen at the price, I think it's around 50 rupees. So for 50 rupees divided by 10,000 into 400 is the actual price. So it's very less. It's like it's very less. Okay, and you will this is a multi-signature account. So once this is confirmed, the system actually does a validation and it will validate. So actually we are going to couple your account to a asset, digital asset, so we can trace your account. So that's the main idea of it. So Metaspec, and then I'm gonna sign it with the valid account, and you can actually observe what are the operations that we're going to use here. So you can see if we list by these operations, you can see change trust is the only operations that is going to go with it. And here if you see, you can see trust line creations, um, and bunch of things. Okay, so the thing is that you cannot do this, you cannot fake the transaction, because if you copy this transaction XDR and if you try to submit it, it will fail because this requires two signatures. So the second signature needs to be um, approved by us. So if you check here in the signatures, so you can see there is no pre-authorized signatures, but you can see the signed XDR over here. So once after we place the signature, we have placed it. Okay, so let's confirm it, and then what will happen is the um, okay, so the TX has failed. So let's um, okay, TX was failed and sign. Okay, there's a error when submitting TX failed. Okay, fine. So okay, let's try one more time. So there can be failures. uh, okay, um, so I think the failure is actually, yeah. So I will have to debug it at the moment. So in the environment we have all the signatures related to them. So I think one might be corrupted because we are constantly changing the signatures for the passwords. um, yeah, so that might be the main reason for this. So I will have to debug it. Okay, so by the way, what will happen here is it will be coupled to a asset. So once it is coupled to an asset, it will be, you can trace the asset. So you user, so through this what we can achieve is, now for example, if the user plays a transaction, um, if there's a multi-signature transaction, for example, if I'm selling a land and two people owns the land, and I will be one person and I will be signing, and then later on my signature was exposed, so I want to delete my signature. I don't want to anyone to use it. So what I'm going to do is I'm going to change my identification account here, but the previous transaction is not yet submitted. So after you have created your second identity account, what will happen is we can have a chain where your identification was switched. So if the transaction submission is done uh, before the stage, then the signature will be valid. So that's the main reason. So you can change your identity. So it's like saying changing your handwritten signature. So it's very simple thing with the blockchain. So it's very secure and simple because um, so handwritten signature, once you placed it, your old deeds, all transactions should be valid, right? So simply they should be valid, they should not be invalid, because at that time you were using it, right? But your new if someone newly created it, it should be invalid. So that can be achieved very simply through this blockchain, the architecture that we're following. Yeah, so the signed in devices, so you can see there are a couple of signed in devices. um, so you can see the location and everything. You can actually remove, so if I revoke all devices, I will have to okay, so I don't want to log in. I think I what I made was I will get the current device will be still there. It will be updated, the token will be updated. Okay, so let's get to the signing part. So when there is an so when there is a so this is actually a custom Stellar laboratory, because sometimes the official one fails, so I just fork their repository, and this is actually the owner is the Stellar Foundation. So here so let me go to the testnet and um, get some old transaction which was okay. So you have an which was submitted recently. So you can see how you can see this on uh, on the laboratory, right? So you can see how we can see it on the laboratory. But if we go to our application and show it, so here you can fetch it, and if I select online, so you see you there is no online transaction signing on cloud. So you can only sign this online. Okay, if not, you can actually save this on cloud. So let me say test signature transaction. So this will allow you to get the hash of the transaction. So you can see you can send this hash to the one user. So for example, it's like this. um, you can you have a transaction, you're gonna sell a land. So it involves at least three people: the lawyer, buyer, and the seller. So you can have this transaction hash and you can save this on the cloud. And what you can do is you can let the user to sign it individually on cloud. So you can see you can input the hash here, and then you can sign on the transaction. So everyone can sign on this and it will be atomic. So for example, if I'm sign off this, I can sign on this. So let's explore the operations. So here you can clearly view operations per the user. So this user has nothing, but this user has one create account. um so yeah, so that's how it's so you can sign pre-authorized signatures. Pre-authorized signatures are very important in the Stellar Foundation, because what this will actually do is, for example, if you sign this transaction now, being a buyer, if you sign on this transaction, you until the transaction is submitted, you have your will to change it, right? You should be able to change it. I mean, you should be able to unsign it at any moment until this is submitted, right? After submission, of course, you can't do that, but until that. But if you actually sign it with your secret key, you cannot do that, because the signature will be stored. So if you go to signatures, it will be stored here, right? It will be stored here. So you cannot actually, you have to manually remove it, but however, it is stored in the cloud, so you cannot do anything. But if I pre-authorize the transaction, what will happen is, it will add a signature to this transaction, but you can, anytime you can disable the signature. You can remove the signature from chain. So that is pre-authorized transaction. So it's on the Stellar documentation, and that was implemented, by the way. Yeah, so that's how it is done. And so the pre-authorized transaction doesn't will not work for this transaction, because it is already submitted. Is not registered under your account list. Okay, yeah. So one thing is, to pre-authorize the transaction through Metaspurk, you need to have it under your account list. So this account is not actually under my list, so that's why you get this error. But if you want to sign it, if you have the secret key, then of course you can sign it. So let me show it quickly how it will work. So let me get the secret key from here. Okay, and pre-authorize the transaction. So if I show accounts, single accounts, so you can see signatures. So you can see pre-auth transaction is there. So you can see the transaction was pre-authenticated, right? So you have a pre-auth signature. So this is the original signature, and this is the pre-auth signature. So yeah, so that's how it is actually implemented. um, so okay, so this is how the pre-auth signature will be present. And then you can actually so you can actually submit the transaction after the pre-auth is done. Yeah, so that is so once the signing and everything is done, you can submit it. But this won't get submitted because it was already submitted. And yeah, so this is most of it. And our next target is to develop the project and the project list, and have the tracking system for each deed and all. So we are still in the process of development of it. Yeah. Yeah, let's have a look at it in the next phase. Thank you.